Welcome to This Explainer. Today, we're doing something, honestly, incredibly fascinating. We aren't going to be parsing massive data sets or untangling complex historical timelines today. Nope. Instead, we're doing something much more grounded. We are observing a single, static image of nature to uncover a brilliant blueprint for cutting-edge, sustainable technology. Let's see what the eye can actually uncover when we, take the time to really look.
Before we bring our subject forward, I want you to prepare yourself for a highly focused visual analysis. Think about it. We spend so much of our day passively scanning things, right? Just swiping past images without a second thought. But right now, let's shift into an active observational mindset. Ask yourself, how much can a single biological specimen actually teach us about high-tech engineering and future wearables? Well, the answer, as you're about to see, is a lot.
Okay, let's dive into this. Presented right here on a stark white background, entirely free from any environmental distractions, is the milkfish. Now, this is a species deeply woven into the local heritage of Tainan. I want you to focus entirely on its overall silhouette and presentation. The very first thing that jumps out? The morphology. Notice that sleek, torpedo-like shape. It's practically a perfect, uninterrupted biological bullet.
When we see a form like this, we really have to ask, what does this distinct shape tell us about how this animal actually lives? Because let's be real, form in nature is rarely an accident. Take a second to hypothesize about the environmental implications of a streamlined body like this. I mean, it literally screams efficiency. This is a design built specifically to conquer a dense medium with absolute minimal resistance. It's a masterclass in natural engineering that human innovators can only really hope to replicate.
Let's break that overall silhouette down into its two distinct halves so we can really appreciate the contrast. On the front half, you've got this wonderfully streamlined, rounded profile. It's incredibly hydrodynamically efficient, designed to literally part the water gracefully. But contrast that with the rear section. The back is this highly angular, deeply forked tail structure. So you end up with the smooth, drag-reducing front perfectly paired with the sharp, propulsive mechanics of the rear. It's just brilliant.
Focusing on structural mechanics, fins, and propulsion.
Now, take a look at the precise placement of these biological stabilizers along the top, bottom, and rear edges. These absolutely aren't random. They are situated at exact, mathematically perfect intervals to provide pitch, yaw, and roll control. It turns that simple torpedo shape into a highly maneuverable organism.
Let's officially catalog the visual evidence we have regarding these fins. First, there is that prominent dorsal fin right on the top ridge. Then, down on the lower half, we can see the subtle, swept-back pectoral and pelvic fins resting almost completely flush against the body. Finally, at the very back, we have that sharply pointed, deeply forked caudal, or tail fin. Now, what's really interesting about this slide is the recurring dark pigmentation on the edges. Specifically, check out those distinct borders on the dorsal and tail fins. That visually highlights the exact sharp trailing edges that cut through the water, basically tracing the lines of highest hydrodynamic stress.
Surface analysis, texture, gradient, and scales.
Trace the coloration from the top down. Notice this striking metallic gradient. It shifts so dramatically from a dark, almost olive gray tone along the top dorsal ridge and fades smoothly into a brilliant, bright silver along the belly. Now, this isn't just an aesthetic feature. Think about how this functions as natural camouflage in a water column. From above, that dark back totally blends into the depths, and from below, the silver belly blends right in with the bright sunlight filtering down from the surface. It is a remarkably effective survival mechanism.
And let's elaborate on the texture for a minute. Those thousands of tiny, diamond-like scales form a completely reflective, seamless metallic armor. But here is the absolute ultimate insight. In Taiwan, these exact milkfish scales are currently being upcycled. Yeah, you heard that right. Through advanced biotech, the natural peptides from these scales are extracted to create Umorfil bionic collagen fiber. We are literally taking this biological armor and turning it into a high-tech, sustainable textile material. How cool is that?
So the crucial point is this contrast here. Just as the completely smooth cranial region of the fish ensures clarity and protects its delicate eyes from turbulence, the bionic collagen derived from this specimen is inherently skin-friendly. When you blend it with premium materials like Tencel, it provides ultimate moisture management and comfort. That makes it absolutely perfect for sensitive skin. It's essentially a true breathable second skin engineered by nature itself.
When we synthesize all these observations together, the conclusion beautifully shifts from biology straight to advanced apparel engineering. Form truly follows function. By taking the hydrodynamic genius of the milkfish and upcycling its scales, we achieve a totally perfect ESG sustainability model. It's a unified design that merges Tainan's local aquaculture heritage with next-generation biotextiles.
And this brilliantly illustrates that this biological marvel isn't just a pretty image, it's a blueprint, which brings us to a dedicated proposal for a true tech visionary, a high-tech skincare t-shirt tailored specifically for tech executive Jensen Huang. By combining the Umorfil bionic collagen, upcycled right from these local scales, with premium Tencel, this garment represents the absolute ultimate fusion of innovation and roots. It's a heartfelt, wearable tribute to the pride of Tainan, tailored perfectly for Tainan's own.
Which leads me to our final thought for this explainer. If we can extract this much innovation, from hydrodynamic efficiency to high-tech bionic collagen, from a single local specimen, what other sustainable breakthroughs are hiding in plain sight? Keep observing, folks, because the future of technology just might be wearing our heritage.